I am your host, Sarah Marino, and we have an exciting presentation for you today. But before we get into it, we will be giving away a NETGEAR backpack cooler. This is great for a day at the beach with your family or a picnic at the park, so stay tuned, and I'll be announcing the winner towards the end of the webinar. Now, you know the drill. If you have any questions during the presentation, feel free to use the chat room below for your questions, and we'll try to answer them during the webinar. If not, then we'll definitely get to them during the end. So without further ado, here to talk about 10 reasons why our customers love the M4300, discover the unique advantages of our 1 gig access and 10 gig distribution switches, is our product line manager, Laurent Macia. Take it away, Laurent.
Thank you very much. Hi, everyone. Good morning. This is Laurent. I'm the PLM for all these smart managed and fully managed switches at NETGEAR. Thank you for joining today. That's going to be exciting, I hope. I want just to tell you as an introduction that we launched the NETGEAR new 4300 series switches last year, a couple of months ago, and we were very surprised how fast these new series switches were ramping. And in fact, we got a lot of backlog at the beginning. So it's going better, but we took some time in December, January timeframe to go to our customers and ask the questions, why did you go to that new series so fast? And that's the result today of our survey. We want to explain how our customers actually really like these new switches. So we will highlight the ways in which those new 4300s can offer major ways to increase, peace of mind. That's really important. And what does it mean for you? Well, that means high security, obviously, zero downtime, and massive performance. So let's go through that. Again, thank you for joining. As a second very quick introduction, a very good stat. Actually, I'm pretty sure you'll be surprised. NETGEAR is actually #1 in the market for both North America, in US and Canada, using NPD data for the entire distribution, and EMEA with the large 10 to 12 countries in EMEA, including UK, Germany, France, Nordics, and so on. We are #1 in 10 gig switching. So no, that's really true. The only thing is that we just count the switches under $10,000 ASP. Why? Because at NETGEAR, none of our switches are higher than that, right? So actually, the most expensive 10 gig switch we have is around $6,000 anyway, so that's pretty fair. And second thing, we only look at units, right, not revenue, because obviously big guys, prestige networking vendors such as Cisco and maybe Arista and all that, they have very high ASPs. So looking at units in Europe and US, for all 10 gig switches available in the market last year, up to $10,000 ASP, average selling price by distribution, NETGEAR owns pretty much that market. And the reason is that we really strive to bring 10 gigabit Ethernet to the masses with a lot of different series, starting from unmanaged plus web managed, smart managed, all the way up to fully managed platforms, and that we do it for many, many years. So today, we are going to look after the 4300 series. So on the right-hand side of that chart, but we have many different lines of switches at NETGEAR, starting from unmanaged, then going to the web managed plus platforms with a very simple to use, easy a web interface. Then we have smart managed switches, more advanced, with again a web interface, but more capabilities. We have 10100 gigabit and 10 gigabit series for each of them. Then we go to the stackable series for smart switches. Then we go to fully managed, and just before the super high-end chassis switch we have on the top right-hand side, the 6100, we now consolidated the portfolio with 4300 series that we placed last year all previous stackable switch series we had in our fully managed switch portfolio. So this is what we are going to focus on today, the 4300s. What that? Well, that's a family. There's many switches. We have 9 different models across the 4300 series. This is pretty unique series in the market because it scales from 24 port 1 gig all the way up to 48 port 10 gig. So that's why we have so many different models. And the big thing about those 4300s is that they all stack together. So yes, all the 1 gig models on the right-hand side here and all the 10 gig models on the left-hand side, they can stack the way we want up to 8 switches, 8. So around 384 ports per stack when we go with 48 ports switches. So that's a very high-end feature because on the market today, we go Cisco, for instance, with the big 3850s, for instance, on the Catalyst side, and they achieve that requirement. But we really try to make it simpler, and you will see that's probably one of the strong reasons why 4300s are so good. So stackable switch series, layer 3, that's the highest end feature set we have at NETGEAR. Everything we do almost on the M6100 chassis switch, we have it available without any software license upgrade on these new 4300 models. So without further ado, let's now see the 10 reasons why our customers love the 4300s. The very first one, and I believe they are ranked in order of importance, so the top reason why our customers told us they love 43, it's because they are very flexible for servers. Why are they very flexible for servers? Because they come with 10 gig copper and 10 gig fiber most of the time on the same models without any module or modular I/O blades to add. So look at those 3 models, 24X, 24F first. We have 48 ports of 10 gig Ethernet, the first 24 ports of fiber, the second half, the last 24 ports of 10 gig are copper. So if we are not sure whether the future servers or storage devices you have or you will get later will come with 10 gig fiber or 10 gig copper, well, you are covered because we have both on all these platforms. If 48 ports is too much, then we have the 12X, 12F on the right-hand side, and the 8X8F. So the form factor is actually smaller. It's half width. We can have 2 of these switches on a single U, and these comes with, again, either 8, either 12 fiber FFP plus ports, either 8, either 12, or the 10 gig copper ports. So that's a very good thing. Why? Because we know that copper is growing very fast. More and more devices, server, workstations, storage arrays they come with copper. But as soon as you are in a more enterprise or high-end segment, very often server vendors or storage vendors still offer fiber because we know that data centers standardize on fiber anyway. That will not change. So that's kind of a lottery. So with these 4300 models, we have as many copper as fiber available with a very good price tag, which is the very first reason why our switches are very successful. So flexible for servers, that was the first one. The second is, we always come down to price very, very fast, right? So that's affordability, how affordable these switches are. And in order to illustrate that, well, I'm going to give only 2 examples. First is that 12x12F 10 gigabit Ethernet switch, the M4300 12x12F that we just reviewed with the last slide. 24 port of 10 gig, 12 fiber, 12 copper. The MSRP, so the suggested retail price, so let's say the online typical price, end user price is under $2,369. So that's, if we compare with the previous generations of 10 gig switches we had before, well, that's very, very cost effective. For a full layer 3 with IPv4, IPv6 routing, including OSPF, including PIM routing, including DHCP relays and radius capabilities, with 24 port line rate of 10 gigs, so 480 gig per second fabric, that's a fair price. The second example, this time we go back to the 1 gig segment for another application. Let's talk about PoE for access with, voice over IP endpoints or access points or IP cameras. The 4352G PoE Plus is a 48 port 1 gig model. All these ports are PoE Plus. This comes with a big power supply so that we deliver 480 watts of PoE power across the 48 ports, and we have those copper fiber 10 gig uplinks on the right-hand side, 2 copper, 2 fiber, again with that flexibility. The official suggested online or street price is around $2,000. Again, that's pretty affordable. Why? Because it relates to the Smart Switch 3300 pricing that you see at the bottom of that slide. Usually the NETGEAR 3300s stackable smart managed switches are very considered as, extremely cost-effective stackable smart switches, which they are. And the equivalent model, well, equivalent is not the right term, but the 48 ports PoE model with 4 10 gig uplinks and 380 watts comes with a $1,700 suggested or observed street price. So the premium between the smart managed switches with layer 2 plus software up to the 4300s with full layer 3 and more advanced capabilities is actually just under 20%. So 20% premium on the 1 gig side is also a very good thing. So with those two examples, we just try to show that, well, sometimes other vendors for high-end, fully managed layer 3 stackable platform, they are not really driven by the idea, of fair price. And we know now that our customers actually feel good about the price they have to pay for those 4300s. So that was the second reason, affordable pricing. Let's go to the third reason. Well, after the flexibility with copper fiber, after pricing, the third reason is actually the feature set, how good the software features are. And I'm not going to stand for a long time on that slide because we do have a pretty extensive, data sheet. It's a big document. Why? Because we have a whole lot of software features on the 4300s. But still, I want to show that it's really a good, strong layer 3 package. In the past, even at NETGEAR, we used to have, license upgrades in order to unlock the layer 3 feature set. That's gone. All the goodness of the layer 3 chassis M6100 platform is available on the 4300 series with advanced security, with all major routing protocols for IPv4 and IPv6 with OSPF, for instance, and even with a future-proof SDN implementation. So we do not have any SDN or OpenFlow controller at NETGEAR. We, for instance, will work with major third-party controllers such as the excellent OpenDaylight or the OVS Open vSwitch, but we do have OpenFlow 1.3 agent so that even if an organization today is not ready for that, for SDN, OpenFlow, and all that, well, by buying a 4300 switch series, they know that they come and they offer future-ready design for a good investment protection should they need OpenFlow later. So I see questions accumulating on the chat box. Please then be sure that we will address all the questions later during the Q&A session. So we know that our customers actually like, that's the third reason they like the 4300s, because the software feature set is extensive. There's probably more than what they need, but well, you know that applications evolve, right? So in the future, which IPv4 or IPv6 traffic will you need to prioritize? That's a question. Which additional security will you need? The security is a good one, because with ACLs, a lot of granularity on both directions with ingress and egress capabilities, including shaping on those access control lists. That's a very good foundation even for future requirements. So software and hardware, but software feature set was the third most important reason why our customers really liked 4300s. So the fourth one was how these 4300 can scale with our customers' business. So scalability is a good one. And I have one typical example for that, because that's always the same thing when we ask the question to our customers. You probably noticed that many of our 10 gig series, the 16 ports, 8 and 8, the 24 ports, 12 and 12, and the copper 24X, these 10 gig series they come with half width. So half width is a very strange form factor, but that's pretty actually good. We can have one switch on one U, because the switch comes with the big ear for the stacking kit. But the good thing is that then, should we need only a few ports at the beginning, we can confidently deploy such a 16 or 24 port switch at the beginning. But should we need more density, or more, I should say, ports, port count in the future, we can then add a second switch into the same U by inserting those middle mounts over there. And then all of a sudden we can stack or just have two independent switches using the other rack mount kit on the box, so that you have this dual switch mounting system. So that's good, because again, very often, especially for small or mid-sized deployments for servers, well, you may not require full redundancy on day one, right? But who knows in the future if high availability, full redundancy will be a requirement. So because it's not even sure you will skip some rack units available in your rack because of the server proliferation, then this is a very good system, because any half-width switch can be associated with another switch onto the same U. So that's a very good thing for scalability in the rack, because we can add port counts and we can procure very high-end redundancy by using stacking on the same U with a second half-width unit on the same space. So the number 5 is back to the stacking story. Remember, we said that those 4300s are actually able to stack all together from the 24-port 1 gig to the 48-port 10 gig switch. So stacking is a good alternative when we don't want to spend that much for a high-end chassis switch, for instance. Stacking is good because we can bring together a stack with several switches and consider them as a single switch. So that's good because it brings ease of management, initial configuration, deployment, but also more redundancy since we can have distributed link aggregation, for instance, and this way go with redundant links in aggregation to the core when we are at the edge. But 4300s go way beyond the simple stacking topology we know. What's the simple stacking topology? Well, that's a ring topology. The Catalyst 3850s, for instance, they go rings as well, and that's what we did, for years at Netgear. This time with the 4300s, we went to the next step, and we actually went to data centers and looked how those spine and leaf architectures were doing. And you may know that for Hadoop systems in data centers, spine and leaf topologies are very popular, but well, they are also very complex with layer 2, layer 3 threshold and all that. We actually adopted this high-end topology and simplified that because we just use stacking. So the result is that we can have, for instance, a collapsed core installation with 10 gig ports at the core and 1 gig ports at the access. And we are going to take two 10 gig units as spine switches, stack them, and the key here is that we can utilize up to 16 ports of 10 gigabit Ethernet per spine switch so that we can have a lot of stacking links in between the two spine switches, and then in between every spine switch and every leaf switches. So the leaf switches at the access can connect redundantly to both spine switches, again using stacking links. So by doing that, we have a very high performance, load balanced stacking topologies, and we have a maximum redundancy because nothing, absolutely nothing can happen to such a 10 gig and 1 gig spine leaf architecture, since the two spine switches are meant to be the master switch in the stack and the redundant management unit in the stack. They can fail over and fail back again without any service interruption due to the 4300 non-stop forwarding stacking topology. So there's absolutely no possible service interruption, and with load balancing, spine and leaf topologies are actually a very good thing for branches or high performance workgroups. So stacking is good because we can form any kind of standard stacking topologies, including ring or dual ring topologies. But again, spine and leaf is one of the major reasons why our customers last year were so fast adopting the new 4300s. Stacking topology and spine leaf. Number 6, it's speed. So 4300s are actually very popular now in this small and medium-sized organization market because they are fast. Let me show that to you. We actually believe that it's the Netgear top of the line. We never had the past so powerful switches. In fact, the 4300 family is divided into two different groups. We have the 48 port 10 gigs, and we have all the other models. On the 48 port 10 gigs, well, they are built upon extremely high-end hardware silicon. And see these indicators, those constants for the table size, 128K for the MAC table, 8K for the layer 3 ARP table, 960 gigs of switching fabric, obviously line rate, throughput, number of routes, 12,000 routes for OSPF. That's massive and that's extremely fast. So latency is very good too. On the lower port count models, we use a different silicon. This time we have 16K MAC addresses, but these 4300s are very fast. And as a matter of fact, the ratio between performance and price points is excellent. So with virtualization, with voice over IP, with wireless networking growth, more than ever, the core, the 10 gig backbone, even the edge, the access layer very often will require serious performance upgrades. And with these table size, we believe that the 4300s are well prepared for that new role. Again, you need to know that, well, between the big ones and the small ones, you have a rule for stacking, because when we will mix those series together into the same stack, then you must have a smallest denominator rule, so that the big ones will be reduced to the table size for the smaller ones. So if we really want to profit and enjoy and benefit from the fastest table size, then we'll have to form different stacks in order to keep those together in order to have the maximum available table size. As soon as we will stack them with the other models, we'll have to use the least common denominator template so that the stack can be formed. So performance is another big one. Let's go to the number 7 together. Downtime. Remember, peace of mind. Peace of mind for a network admin very usually comes from performance, good network health, but also it comes from high availability, how redundant, how the network can survive in case of hardware failure. And with 4300s, the no downtime thing is crucial. Let me explain that to you. Very simple. 4300 series on the market is one of the only few with that non-stop forwarding capability. When we want to compare with the big, large Cisco portfolio, only the Catalyst 3K, the 35 and beyond today shipping 3850s offer this kind of non-stop forwarding. What does it mean? It means that in every stack, we always have a management unit. We call it the stack master for a long time at NETGEAR, but the official name in the software is the management unit. Let's say you have the management unit on the first switch on the top left. Then you have a second unit in the stack elected or programmed to be the redundant management unit, so that we have a failure hardware issue on the management unit. The redundant management unit can be elected as the new master and take over for the layer 2 forwarding tables, for the layer 3 routing tables, for SNMP, and so on and so forth. This process of fail back, fail over, fail back, fail over again is totally hitless on the 4300s. It means that if you pull the plug, if you remove the power cord on the master switch without any service interruption for all the traffic in and out across the stack for all other models, you will really observe non-stop forwarding failover. So I'm going to give you only one example. Let's say you have this stack as a edge access layer stack somewhere in a network. You have the master unit, management unit, and the secondary management unit all linked together with the stacking, and you have this uplink going back to your core. If you have your CEO connected onto the last switch, attending a web conference for investors, for instance, should the master management unit fail, if this is not NSF stacking architecture, the whole stack is down and the CEO is getting disconnected from the web conference. And believe me, you don't want that to happen. So that's the goodness of 4300s with non-stop forwarding. When the master switch fails in this unlikely event, the redundant management unit is all of a sudden instantly taking over, so that the TCP connection for the web conference or UDP whatsoever, all those sessions are kept intact for the CEO talking to the investors during the web conference, and everything will take the other route to the core for the WAN and the internet. So hitless failover and non-stop forwarding is a very, very crucial, critical feature for any stacking topology, and that's built in the 4300s, unlike most, if not all, equivalent series in these layer 3 stackable, affordable platforms at competition. So that's a very important one. Okay, we are approaching the end. We have the number 8. When we talk to our customers, they said that, well, they went to the use cases and how they were deploying 4300 so far. So the access layer is very important still. Well, we talked a lot already during this webinar today about servers and core and backbone, but we don't forget that quantity of deployments, still go to the edge because there's a lot going on with consolidation, with centralization of multiple traffics, including voice over IP, data production, video at the edge. And usually PWE is a very important driver for, access layer refresh in many verticals. So I got my example with the CEO here because it's very valid again. We all know that stacking switches at the edge is good because we actually reduce the number of individual switches to manage should we need 100, 200, 300 ports in one building in a K-12 infrastructure. It's always better to go stack, right? Because you will deploy those switches, and after that, for management, all the network will see this group of switches as a virtual chassis unit, as a big switch, and from a management standpoint, you will just manage one big switch. But don't forget that even at the edge, high availability can be very good. It's not always a requirement, but when it is, it's extremely important to make sure that you have your master management unit linked up to the core and using a lag, for instance, using LACP, forming a second physical link with the backup management unit so that in case of a failover or a failback, you get this LACP protection with both load balancing and rapid, immediate, hitless failover capability. So PWE at the edge is one great asset for the 4300s because we can do that very cost effectively in comparison with lower end smart switch platforms, but providing this HA label on top. Number 9, high availability. Maybe the most important criteria for servers is HA, right? And that's another strong reason why a lot of customers went to the 4300s almost immediately at launch. And we go back to those half-wave 10 gig switches again. Why? Because remember the price tag we were discussing at the beginning of that presentation. I remember it was the second reason why 4300s were actually really much appreciated by customers because the price point was good. Okay. Why? Because 24 port was actually around $2,200. So instead of a non-redundant single point of failure installation for the servers, 4300s really allows for a redundant installation. Instead of one big switch, we will have 2 compact half-width switches instead that will just stack together by upgrading the port settings to the stacking mode between the two so that every single server, every single hypervisor, every single arrays or storage device can go with redundancy can go to both switches using most of the case LACP connections. So instead of a single point of failure Unix switch we should really advise redundant installation without big difference on the final price tag, especially if we go with the 8 and 8 instead. Okay, so high availability installation, high availability deployment is not only for enterprise anymore. With 4300s, we can offer that to small and medium customers under the price of a previous big fat non-redundant 10 gig switch. We can now go with two small ones that we redundantly connect using stacking. Last big reason, full power redundancy. So after all these other reasons, our customers actually told us that, well, another big thing was that we actually simplified the redundant power options for our switches. Because in the past, very often we had to use external redundant power supplies in, kind of a extensive and expensive RPS, EPS external units. So that's more cost. It takes another U in the rack, and that's not very elegant. So this time, for all full width models, we now have standard 2 PSU base with modular power supply, so that we can just add a second PSU for instantly, without any configuration, bringing power redundancy on the 10 gig switches, for instance, and or 1 gig non-PoE switches. And when the switch is actually PoE, adding a second PSU automatically doubles the PoE budget, so that we have power share capabilities between power supplies to go up to the full PoE plus provisioning. So full PoE plus 30 watts across 24 or 48 ports. So the power redundancy, the power provisioning, the hot swap dual modular redundant PSU bay installation we have on the full width models is actually another good reason why customers actually told us they were liking 4300s. So I think we went through all of them. Flexible server connections, good price points. These switches are affordable. They really provide world-class feature set, especially with high-end layer 3 features. They scale pretty well, including with 10 gig when we have two different 10 gig switches, doubling the port count in a single U for a rack for servers. They can actually form spine and leaf stacking topologies with 10 gig switches at the spine and 1 gig switches at the access as leaf switches, so that you have a big giant collapsed core up to the fully line rate capability, because 4-port 10 gig can be used for any single 1 gig switch, going redundantly to both spine switches. These switches are actually very fast. The hardware table size is massive at the top of the line for us. They don't come with any risk in terms of downtime, because they are all equipped with that very high-end non-stop forwarding capability. So a stack just cannot stop. It just can't happen, because the failover and the failback capability won't bring any service interruption across the stack. They are good at the access layer for convergent installations when we have PoE stacking architectures, for instance. They are very good for high availability for servers, because again, we can have cost-effective dual redundant installation instead of a single point of failure for 10 gig top of the rack switches. And last but not the least, those switches simplified the power redundant options, because all the full width models come standard with two PSU slots, so that a second optional PSU instantly brings power redundancy or power share capabilities, EPS capabilities for PoE models. So thank you very much. I hope you learned good things about these 4300 switch series with us, please use the chat box from now on because we are going to go over the QA session. Again, thank you very much for your attention today. And Sarah, I can turn it back over to you.
Thank you, Laurent. Thank you for that very informative presentation. That concludes our webinar for today. Thank you everyone for attending, and we'll see you soon.